Hi again, welcome back. Here I'd like to show you how you get the derivative of f with respect to z. Now this will be a little bit longer than the previous video, but I'll walk you through it step by step. So let's take a look. So again, here is the final expression that we'll use, and right now we're focused on getting the derivative of f with respect to z. And the end goal that we know we want to get, because we've seen this in the first video, is that the derivative of f with respect to z is f times the quantity 1 minus f. So how do we get here? First, recall that f is equal to 1 over 1 plus e to the minus z. That's the sigmoid function. And one rule of math is that 1 over some variable a is the same as a raised to the power of negative 1. So let's rewrite f like this: 1 plus e to the minus z, quantity raised to the negative 1 power. Now another rule of calculus that we'll apply next is that the derivative with respect to a of a raised to some constant n is that constant n times a raised to the power of n minus 1. And again, don't worry, these are rules of calculus that you can look up in Wikipedia, and I'll just show them to you now so that we can see how we use them. So now we can write the derivative of f with respect to z is, so now we can see that the derivative of f with respect to z is negative 1, where that negative 1 came from the power of the previous equation, negative 1 times quantity 1 plus e to the minus z, now raised to the power of minus 2, where minus 2 is taking minus 1, and minus 1 is equal to minus 2. Now, if you look at what's inside the parentheses here, the 1 plus e to the minus z, we also need to take the derivative of that. So, derivative of 1 plus e to the minus z with respect to z. And this is actually another application of the chain rule. It's okay if you don't see exactly why that is, but this is just a rule of calculus that will apply. So what's the derivative of 1 plus e to the minus z with respect to z? Well, we can use this other rule, which is that the derivative of e raised to the minus 1 times z is going to be minus 1, from that power, you bring it down, minus 1, times e to the minus z. So now we can rewrite the derivative of f with respect to z as this: minus 1 times 1 plus e to the minus z raised to the minus 2, so that hasn't changed. And now we replace derivative with respect to z of 1 plus e to the minus z, we replace that with minus 1 times e to the minus z. Okay, so next, look at these negative 1s. We can cancel them out because minus 1 times minus 1 is just 1. And we get this expression here. The derivative of f with respect to z is 1 plus e to the minus z raised to the power of negative 2 times e to the minus z. And technically you could actually stop here, and this would be something you could use in your code. The following steps that you're going to see next, all on the right hand side of this slide, are really just moving variables around so that you can finally get that final expression that you see on the bottom right, which is f times 1 minus f. Okay, so this is pretty fun, but don't worry, everything that you're going to see on the right of this screen is just going to be moving things around so that you can rearrange it to say that it's f times 1 minus f. Okay? Now, one rule of math is that positive 1 minus 1 is equal to 0. So you could write the derivative like this, where on the right-hand side you see that there's a plus 1 and a minus 1, and that doesn't change the expression because when you add 1 and then subtract 1, you're really just adding 0, so you're not changing anything. Now over here, this factor on the left, here's another rule of math. A raised to the power of minus 2 is the same as 1 over a raised to the power of 2. So we can rewrite this expression like this, where on the numerator you have what you had on the right hand side at the top, and you can see that this expression on the left, raised to the power of minus 2, is now in the denominator as that expression raised to the power of 2. So the next rule of math that we're going to use is this one. A plus b all divided by c is the same as a divided by c plus b divided by c. So now we can split this expression up into two pieces. So there's going to be the one on the left and the one on the right, where you have in the numerator 1 plus e to the minus z was on the left-hand side, and then you put that minus 1 on the right-hand side. And a nice thing you can do next is to take that numerator, 1 plus e to the minus z, cancel it out with one of the 1 plus e to the minus z's on the bottom. So now that's just raised to the power of 1 instead of 2. And let's clean this up so it looks like this. So the right-hand side didn't change, we've just simplified the left-hand side. Now the next rule of math we're going to apply is that 1 is the same as 1 times 1. So this first term can be rewritten like this. 1 is now 1 times 1 divided by that denominator. And here's another rule of math. Negative 1 is the same as negative 1 times 1. So that second term can be rewritten like this. That minus 1 is now negative 1 times 1 divided by this expression on the bottom. And you can see that the denominator changed because we applied this rule, which is that a squared is the same as a times a. So now it's just 1 plus e to the minus z times 1 plus e to the minus z. And recall that the sigmoid function for the logistic regression model is defined as f equals 1 over 1 plus e to the minus z. So now we can play a game that's sort of like Where's Waldo, where you're looking inside this equation and looking for instances of 1 over 1 plus e to the minus z. Let's take a look. Here you can see that this is 1 over 1 plus e to the minus z, so we can call that f and do a substitution coming up. Here again, you see that this is also 1 over 1 plus e to the minus z, and we can also substitute that with the variable f. And finally, here you can see minus 1 divided by 1 plus e to the minus z, and we can substitute that as negative f. So when we do all these substitutions, we just get 1 times f plus negative f times f. And if we look at these magenta colored positive f's, we can actually factor that out. So we just have f times the quantity of 1 plus minus f. And then the last step is that adding negative f is the same as just subtracting f. So you get this expression that we saw in the first video, which is that the derivative of f with respect to z is actually f times 1 minus f, where f is the sigmoid function. Pretty cool, huh? Now in the next video, we're going to get that last piece, which is the derivative of the loss with respect to f. So let's take a look at that in the next video.